Newton. He was the father of physics, and his work was the foundation of this science for a really long time.
Until Einstein came along. But there's still one thing from Newton that's very influential, even in today's physics. The 3 laws of motion. Law number 1. Every object in motion will stay in motion, and every object at rest will stay at rest unless an external force acts upon it. This is probably the simplest law of all 3, and it would be best explained in space. Except we can't go to space. So take for example Meegan. Meegan is at rest, which means he isn't moving, and he could remain that way for hours, days, or even weeks, provided he didn't die of dehydration. Of course, if a force from outside decides to act upon him, say a little push from Vianney, he will start moving. Now we all know that he's going to stop, but this is also explained by this law. Outside forces are everywhere, air resistance pushing him back, friction on the wheels, his own weight applied downwards, etc. But if we removed all of those, we'd have Mike infinitely moving in his wheelie chair.
Law number 2. The acceleration of an object as produced by a force is directly proportional to the magnitude of the force and inversely proportional to the mass of the object. The second law sounds more complex, but it's just a fancy way of saying that the more mass an object has, the more force you need to make it accelerate at the same rate as a small object with a small force. Let's set another example. Pepe here is a wimpy guy, but he has no problem making this Yoda doll accelerate. But if we give him something heavier, he won't be able to make it go as fast. On the other hand, Vianney is much stronger, so her Yoda doll will have a higher acceleration, and she can move the heavier object with more ease.
Law number 3. Every action has an equal and opposite reaction. The third law of motion states that applying a force to an object in one direction will yield a force just as strong going to the opposite direction. This is the reason why we have friction when an object moves along a surface, and it's the basis of rocket propulsion. But we will recreate it in a smaller scale. When you jump, you apply a force down to the ground, but your body moves up. This happens because all of the force that you applied downwards will return in the opposite direction, upwards, with the same magnitude.